Hi students, I'm going to go ahead and take time now to go over your homework answers with explanation so you'll understand how to apply those laws of exponents that you've been reviewing. So remember, when we were multiplying like bases, we want to add our exponents. So even though we have a number instead of a variable, the rules still apply. This would be 15, where we add -4 and 8 to get 15 to the fourth power. And I'm really just concerned that you understand how to apply the rules of exponents, laws of exponents, so I'm not really concerned with the exact value, evaluated rather. You can put it in your calculator, of course. For number 2, understand that any variable that you do not see an exponent for does have an understood 1. Because we do have like bases, we again do want to add all of our exponents. So if we add 7 and 8, we get 15 plus 1 is 16. So you should have had 8 to the 16th power. Next, for 3, we want to take a look at this carefully and notice that we do have a term to a 0 power. Recall that from reviewing your laws of exponents that anything to the 0 power equals 1. So multiplying by 1 will not change the value in our answer here. So really what we're concerned with is multiplying these two terms here. We want to multiply 3 times 2, which will give us 6. And again, remember that when we multiply like bases for our variables here, we will add our exponents. So 4 plus 2. And of course, I would expect that as you work on these, you learn to pick up and just use the rules in your head instead of writing it out. So you should have 6m to the 6th power n to the 7th. For number 4, when we take a look at this one, we notice that we do have negative exponents. Remember that our negative exponent rule says that we can invert the exponent to make them positive. So I'm going to take this b to the -5th term and move it up top and cross it out from the bottom. And take our b to the -3rd term and move it to the bottom and make it positive. Next, I want to simplify our integers here. We have -28 divided by 7, which will give us a -4. Notice we have an exponent of a largest on the bottom, so when we evaluate this, we want to subtract our exponents, leaving our a on the bottom, and subtracting the 11 minus the 6. We could leave it up top, but if we do 6 minus 11, then, and I'll just illustrate this over here, if we do a to the 6 minus 11, we'll end up with a to the -5th, which will then get moved to the bottom as a to the +5th. So generally what I do is just leave the variable where it is largest, where the exponent is largest, and then subtract. So 11 minus 6 here will go on the bottom. And then notice with our c's have the exact same value, so any number divided by itself equals 1, so we can actually simplify by eliminating those. Our b's, don't forget here we have b to the 5th and b cubed is largest on top, so b to the 5 minus 3 up top. And when we finish, we'll have -4b squared over a to the 5th. Next, for number 5, recall that anything with a negative number to a even power is not any different, well, in this case for -1 times -1, or as -1 squared. Meaning if we multiply two negatives together, or any even number of negatives together, it will end up with a positive. So a -1 to the 10th power is a +1. So this would give us 1. We have x to the 5 times 10. Remember that power rule says that a power evaluated to a power is the product of the, will have the product of the exponents. So y to the 6 times 10 up here. So we should end up with x to the 50th, y to the 60th. Next, for number 6, remember any number to a power we are going to evaluate as -2 times a -2 times a -2, where we will then multiply our exponents of our variables, giving us a to the 3rd, b to the 21st. On the bottom, we can put a negative 1 in there if you like, and a negative 1 to an odd power. Remember, negative 1 to the 5th means we'd write it 5 times. A negative, while these two would give us a positive and these two a positive, when we multiply by a negative, we'll end up with a negative. So we will end up with a negative in our denominator. So just remember, a negative number to an odd power will be negative. And then we'll have a, in multiplying our exponents, a to the 20th, b to the 10th. So further simplifying, recognize a negative 2 times a negative 2 is a 4. 4 times a negative 2 is negative 8. We will have a negative on the bottom as well. And our a is largest on the bottom. So I'll have a to the 20 minus 3 on the bottom. B, our exponent, is largest up top. So we'll have b to the 21 minus 10. And negative divided by negative gives us a positive. If it was negative, we would keep the negative with our numerator. So we'll have 8b to the 11th divided by a to the 17th. All right, so next for number 7, notice within these quotients we have our denominator here being squared, and up here our numerator being squared. So you always want to take care of powers first. Remember your order of operations. We want to take care of exponents before we divide. So to start off, I'm going to leave my numerator the same, and then evaluate 3 squared, which is 9, and z to the negative 3rd squared is negative 6. Because I have a negative exponent, I'm going to go ahead and write it upstairs. So that'll be 2x to the 4th y cubed over 9. Next, I have 3z to the 7th squared. Squaring 3 gives me 9. And then z to the 14th over 2xy to the 6th. So I'm just going to bring this down so I can multiply it by our first quotient. And next I want to simply multiply numerators and denominators. So 2 times 9 gives me 18, x to the 4th, y cubed, z to the 14th, over 9 times 2 is 18, x, y to the 6th. Simplifying, our 18 divided by 18 is equal to 1. We do have an understood 1 for our exponent of x. So my x is largest up top. 4 minus 1 is 3. My exponent for y is largest in my denominator, so y will remain in the denominator. 6 minus 3 is 3. And z to the 14th, there's nothing to simplify, so I'll just write that up top, and I'm done. I think I forgot z to the 6th, didn't I? I did. When I rewrote it, I forgot z to the 6th. I apologize. So actually, z to the 6th times z to the 14th. I should have z to the 20th here. I'm sorry. And that will carry over in my final answer as well. Okay. One thing to keep in mind, especially with a problem like this, is that as long as the rules are applied correctly, you may definitely have thought about doing this in a different order, and that's perfectly fine, but we should all end up with the same value at the end. Moving on to number 8, we've got 5 times negative 2, which would give us a positive 10. We are going to add our exponents, so m cubed times m to the 1st is m to the 4th. Oh, forgot my negative, sorry about that. And n to the 1st times n cubed is n to the 4th as well. And there's nothing further to do there. Next, for number 9, when I take a look at this, I see a couple of different things. I first see that in this product I have something being squared, and I also notice something to the negative 1 power. Recall that when we have an exponent on the outside, We simply want to invert that part of the expression here to the bottom. So I'm going to take all of this and move it to the bottom. Of course, the exponents do not change on the inside, but what that does give me is a positive 1 as my exponent on the outside now. So I'm just going to cross that out since I moved it downstairs. Next, I'm going to evaluate this by squaring what we have up here. A negative 1 squared means negative 1 times negative 1, which is a positive 1. A to the 4th squared is a to the 8th. B cubed squared is b to the 6th. All over my 2a to the 5th, b to the 6th, all because it's to the first power. So I don't have to multiply exponents there. Combining or multiplying these two terms up top, 7 times 1 is 7. A to the 9th, remember I'm adding that 1. And b to the 7th from adding the 1 there. On the bottom I have 2a to the 5th, b to the 6th. And of course some of you may be seeing areas where you could cut some steps out, and that's perfectly fine as long as we end up at the same spot. And lastly, 7 halves cannot be reduced. My a is largest up top. So remember, this is like having 9 a's on top and 5 a's on the bottom, where 5 of them would cross out. So that leaves me with a to the 4th up top and also b to the 1st, because 7 minus 6 is 1. And I'm all done. All right, and now we're on our last problem. When we take a look at this, I want us to first recognize that we need to multiply these coefficients out here. So we have a negative 9 times a 1/3 times a negative 2. When we evaluate this, we get negative 9 times negative 2 is positive 18. 18 times a third is the same thing as 18 divided by 3, or 6. So my coefficient I know is going to be 6. Because I do not have exponents on the outside, I'm just moving straight into multiplying my x's, where I add my exponents. And I will do the same for my y's. So when I add 3 and 5, I get 8. And when I add 4 and 2, I get 6. And that's all there is to it. I hope that explanation helps, guys.